Anyway, without further ado, I'd like to get started with today's webinar. The topic is flexible automation, a game changer for the electronic manufacturing industry. I'm Philip Stoten. I'm a writer for Forbes and for various industry publications, and I spent the first half of my career in electronic manufacturing and the second half of my career writing and talking about it. So it's an industry that's very close to my heart and very important to me, and one that it's fascinating to watch it develop and change as we go through some very, very challenging times. We have two wonderful guests with us today. We have Johan Halling, who is an industrial advisor with a huge amount of experience in electronic manufacturing services with Celestica, with PartnerTech, with Escatec, and various other companies, and has spent a lot of time involved in the automation process. We also have my old friend Mattias Andersson, not so old actually, but a very good friend who is the founder and CEO of MTEK with again, a huge amount of experience in the whole manufacturing process, but specifically where automation really hits the road and can really have an impact on the business. What I want to do is start by just talking a little bit about what's going on in the industry right now. And before I do that, I just want to remind everybody that we'd love to take questions from you during this session. We'd love for you to interact with us. So you've got a question and answer tab, and you've also got a chat tab there. Feel free to just put questions or notes as you come to them anywhere in there. And when we get to the latter part of the session, I'll ask these two learned gentlemen to answer some of those. But when we look at the challenges for the industry, we've gone through this huge disruption. It started with a disruption in the supply chain. It very quickly became actually a localized disruption in supply chain. It very quickly became a global issue, and then that was followed by a big disruption in the demand side of business. So we've seen those two disruptions, and then to make it this almost perfect storm of disruption, we've added this workplace disruption in terms of social distancing and all of those challenges. So we've created within this crisis, we've created a pressure on manufacturing companies that gives us this absolute need to become much more agile, much more able to adapt, and much quicker to pivot our business. And that's definitely true of this crisis. But the truth is, it was already happening with previous crises or previous challenges like trade wars and tariffs. COVID-19 seems to be a bit of an accelerant for that, and it's certainly the biggest crisis that's faced the industry that I can remember. So for me, what we're seeing is an accelerated need for digital transformation. One of the clear things within this process is we've seen an element of digital haves and have-nots. Those that have got data can see what's going on in their supply chain, can see what's going on in their manufacturing, and are more likely to be able to pivot than those that don't have data. So that's become very important. Another trend we're seeing that I think is really challenging for the industry, and again will drive this need for agility, is a concern about existing supply chains and overdependence on certain locations, combined with a desire to restart economies by bringing manufacturing home. So we're seeing this anti-globalization feeling and this drive to nearshore or reshore, or whatever term you want to use there. And we're seeing a kind of a challenge between regionalization, nationalization, and globalization. And for me, the answer is digitalization. So again, I think that requires that need. And another huge pressure is basically we're in a position where the economy is not in a great state. So budgets are under pressure, and any investment that people are going to make in this digital transformation needs to show a really clear ROI. So we've got quite a challenging state to manage and to deal with. So what does that mean for EMS companies? It means manufacturers need to be more competitive, not just where they are, but also in higher wage cost environments. And to do that, they need to look at automation and digital transformation generally, but specifically looking at those labor-intensive processes and figuring out what they are. When you look at automation, and we think of automation traditionally, we think of cranes and robot arms that live inside cages and are very fixed and are very complex and are very heavy in terms of investment. That's not going to work in the future. What we need is something that's much more adaptable, much more flexible, and can suit a very high mix environment. The digital thread is part of that digital transformation, so that has to exist through every part of the manufacturing process, and automation can play a part in that digital transformation, and it has to play a part in that connectivity of the digital thread. And that's what will allow automation to collaborate and be part of a digitally enabled manufacturing ecosystem, which I think is what we need to consider as the next stage of the industry to get us to that agile state that is more adaptable, faster to pivot, and more resilient to the next crisis. And lastly, automation needs to be simple and intuitive to set up, to program, and to manage. It needs to not be something that takes days and days to do. It needs to not be something that needs someone with a huge amount of experience and qualification to do, because that person might not be available when we need to change it and when we need to adapt it. So we've kind of setting ourselves up for some real fundamental changes in the industry. I don't think COVID-19 is the reason for these changes, but I do believe it's the accelerant. I believe it's the thing that's putting this higher and higher on people's agenda. And when we get past dealing with the urgent, we start to deal with the important. And this is definitely in the category of important for recovery and important for the future state of the electronic manufacturing industry. And that's something that I think we need to consider, and that's something we'll be discussing a little bit here today. I am going to not take too much of anybody's time, and I'm going to hand over to Johan Halling, who, as I've mentioned before, is an industrial advisor with a huge amount of experience in the industry. Johan, can you give everybody a quick introduction to yourself and an idea of your background, and then we'll get into some detail of the topics you want to discuss.
Thanks, Philip. Just to give you a little bit of my background, I've spent the last 15 years in the contract manufacturing industry. It has contained electronics, system integration, sheet metal, and plastic as well. So fairly wide in terms of the technology base. I've dealt mainly with industrial products, but also done some smartwatches and cell phone technologies as well. So being able to look at high mix, low volume environments, but also very, very high volume and very low mix. In addition to that, I have covered various types of service industries, including design of products, bringing out high-tech solutions to low-tech industries, so game changers in those environments. So that's my background, and my perception is, or my view, is that we're facing a new world, but it's not the fundamentals of a product or a production process that change. It is the output that we are considering when we are looking at those two. And also the environment in which the production process or the product will function in the future that is changing. And that is a fundamental change in the industry. Okay,
so let's start to explore some of the challenges you see in automation right now. What is it that you have to go through to figure out what can be automated and what can't be? What do you see as the key challenges?
Well, firstly, we have for quite some time seen that the competitiveness is increasing. More and more of our customers want unique products in lower quantities. So, and they want to adapt them to their particular customer needs. So in doing that, they need the same efficiency as a need for a high volume product. At the same time, they can buy from wherever in the world. and they go wherever they want, which means that competitiveness cannot be limited to a particular region. It needs to be global all the time, so that when we are facing the challenges and why we need to go to a different style of automation, the challenge is that traditional automation is too slow to support most low volume and medium volume products. It takes too long time to implement and cost too much. And in addition to that, if we implement it, it's too inflexible. It's a cell, it's a unit that solves a particular issue. And with the short product life cycles or high mix production site, it is tricky to find the applications where it makes sense. So the limitation is to some extent the technology in that.
Yeah, and interestingly, that doesn't just mean it's the products that are in particular volume. It also means it sits perhaps in just the latter part of a product life cycle, whereas it would be better if it sat more at the prototype, what people call bridge production, and through the whole product life cycle. But because it is so rigid and expensive, it tends to get saved for the, for the mature products only, I guess.
Absolutely correct. Absolutely correct.
Okay, so when you're selecting a process to be automated, what are the key factors that you're looking at? What makes a process appropriate for automation?
Well, when we're looking at the automation that we already have in our factory, it's not that we are not automated. We have the SMT machine, which is essentially an automation. We have wave soldering processes that provides an automated process. We have conformal coating, among others. And here we need to make sure that we have automation supporting these processes. Often where we lose efficiency and time is in between the processes that we are deploying, which are already automated. The automated processes need to be more flexible. We need to be able to change program in an SMT line in between each board so that we can utilize the dual channels and so on. Further, if we're looking at the key factors and what is going to drive the automation, is that when we're implementing automation, we have a tendency of doing more inspection. And that comes out of the quality requirement for an automated process. When we go to robotics, if we deploy this approach and take it one step further than just placing an inspector at the end of the robotic line, we will have a more robust process. But then we need to have feedback loops, we need to have closed systems, and develop the technology and also our thinking about it. I have too many times seen that companies are deploying AOI and then they have an inspector looking at the results of the AOI, checking that it's correct. And going forward in the future, if we don't do things differently and we find a new type of automation that can drive us forward, we will have automated processes supported by inspector and technicians in mass. And instead, we need to focus on standardizing our interactions with the automation. And we need to implement more SPC. We need to have centralized AOI as a control station. And process need to be validated rather than all the time going back to verifying the results. There are some benefits moving forward as well, and that's when we're looking at how to transfer the products, because in the environment that we're facing, we need to produce products closer to where they're going to be consumed. I think the recent development with the pandemic shows that products cannot be transferred so far because we're exposed. And we need to look at lower volume and cater to a specific market. And with a properly designed and proper automated process and with proper robotics, we can actually transfer the tacit knowledge or remove the tacit knowledge required to produce a product. And thereby it will be easier to transfer it than a normal manual operation of the same type. And that is going to change the game relating to low-cost labor. If I'm looking further to the key factors that we can consider, there isn't a change when we go from electronic assembly with an automated process to manual. It needs to be properly developed, properly researched, properly designed. But if with the manual process, we have a higher degree of variability, which means that the automated process and the robotics will be easier to control in the future as well. So instead of choosing simple operations like robotic soldering, we need to consider the more advanced, more complex processes and find ways of deploying automation for those, right? And key is also with a robot, it does not introduce any variability other than when you have setups and full facility interruptions. If power goes off, of course you have an issue. With a manual process, you introduce variability every time the mind or the body of the operator wanders off. And it doesn't need to leave the workspace. It's just losing the focus on what needs to be done. And here we have a opportunity for automating if we are considering those processes. So the key challenge that I see for automation and robotics moving forward is to ensure the highest degree of flexibility, transferability, and replicability without compromising quality and traceability of the production process. And that is something that the robotics and automation can offer. And when we have challenges in this respect, that's when we need to go to automation, not the opposite. We have had a tendency of deploying manual processes in order to ensure these three aspects and not automation.
Yeah, no, it's fascinating, and it's interesting what you say, Johan, about the SMT line, which is kind of the if you like, the meaty part of the EMS industry. It's quite an automated process. It's basically a production line, but once stuff comes off of there and once stuff is being inspected and maybe pushed off because there's an inspection thing, everything becomes a very, very manual process, and we rely a lot on that tribal knowledge, and that's dangerous because it might mean that it's better on the first shift than it is on another shift, or it's better in the morning than it is in the afternoon, and it shouldn't be that way.
Yeah, that's absolutely correct, and that comes back to our interactions with automated process. We tend to have SMT lines which do not have a closed loop between SPI and screen printing, for example. We do not centralize AOI so that we can compare the data coming out and actually have high competence or even artificial intelligence relating to the evaluation of the data we are seeing.
Yeah, and I think what's fascinating is when you mention things like AI, and we'll get into this a little bit later in the panel part, is those tools are much more available than they were 5 years ago. So there are some really interesting opportunities there. What I'd like to explore a little bit now with you, Johan, is the experience that you've had, the projects that you've done in terms of automations, and what have you learned through that experience?
Well, what I've really come to focus on and understand is that the automation and the requirement for automation doesn't change any of the basic requirement on the design process. It's still the same. If we want to have a high quality product, it needs to be producible. However, if we have manual interventions, or if we have a badly designed product, we need the manual interventions to get the product out. And it is a compromise to the quality of the product, the more intervention that we actually have. And that is key. Another conclusion is that automation is not a replacement for industrial engineering methods. Six Sigma will have the same validity. Lean will have the same validity. But if all that base work is done and solidly implemented, the automation provides an additional benefit to those methods. So no change in terms of what the engineers on the factory floor needs to do, or the design engineers. If we're looking at collaborative robotics, it's even more interesting since it allows for a physical separation on the factory floor without compromising efficiency. A number of industries have faced that in the past. If we are looking at the nuclear power generation, they have always faced the kind of challenges that we have with the pandemic now, in terms of exposure to radiation for the operators. So they have been forced to automate and limited the exposure, and also have the separation towards the sources of radiation all the time. So they have already gone through this. And today it's a very automated process. We will need to do the same. We need to approach the factory environment from a totally different health and safety standpoint than we have been in the past. And the final conclusion that I made is that the real game changer is that collaborative robotics allow for the manual intervention to be introduced where it's necessary and makes economic sense. So the manual work needs to be introduced by design. Today, we are approaching automation from the completely opposite side. We bring it in from a design standpoint where it will support the manual processes, and that will be a major change.
Yeah, I think when you look at those projects, it's really interesting that things like the physical separation have suddenly become very high on people's agenda, and all those things are changing, and it really is important that robotics and automation become part of that lean toolkit and doesn't replace lean. So as people are going through their lean kaizens in a particular process, they think of automation as one of the tools they can use to do that, rather than we can either have a lean process or an automated process. I think it's really important to consider both. Johan, thank you for your time. I'm going to get you back in with us once we get to the panel discussion. I want to bring in Mattias Andersson, who is the CEO and founder of MTEK, and explore a little bit about what all that means, what all those challenges mean to someone who's actually producing these kind of products and actually deploying them and working with these EMS companies to get products out there. Welcome, Mattias. Can you give me just a 2-minute introduction to yourself and to MTEK?
Yeah, sure. Mattias Andersson, CEO, founder of MTEK Industry. Been in the business for some 25 years. To start off, I was one of 6 people within the Nokia data management team. So we did the first machine learning and closed loop machine learning and artificial intelligence implementations back in '96 something. Been working within industry ever since, a lot of within contract manufacturing, different product owners, writing software, supplying to some of the biggest machine manufacturers of the world. Wrote 4 books on the subject, production and design, together with colleagues. Traveled 6 to 8 different countries, working a lot outside of Sweden. So
yeah.
So MTEK, what we do is that we develop solutions and software to simplify manufacturing, basically. So we have our different applications and offerings to support the continuous growth of the electronics industry, basically.
Okay, so when you look at what you're doing in terms of developing adaptable automation, what are the keys to doing that? What are you looking for? And when you think of robotics, how do you think of it in terms of what it can empower on the factory floor?
I would say I would go back in history and look back on the development of the SMT machine and the ways to program it and the ways to use it. That was not so standardized some 25 years ago. It was quite cumbersome to program. It was all the packages, everything. There was a lot of standardization work ongoing. So that journey the SMT side has been on in terms of standardization has been really important. It all comes back to simplicity. So if we can simplify every activity that we need to do, that is super important, because simplicity means that people can understand it, they can use it. So that's the side from the user side, but also from the perspective of making sure that the solutions are reusable and redeployable. And in order for us to do that, we put a lot of effort into the software development to make sure that we actually augment the human capabilities. So, and I think the perspective will be able to reuse, not being forced to throw away your quite expensive robotic solutions or automation solutions, but you're actually able to redeploy them very quick. That goes in line with what Johan says regarding the high mix, high volume scenario that we're entering into.
Yeah, and that's where, you know, you kind of figure out, are you a company that provides software? Are you a company that provides hardware? Or are you a company that provides service? And I guess the answer is you're looking to provide a solution, and it's, you know, it's a whole mix of those that allow you to do that. So when you think about that, how important is connectivity and collaboration on the factory floor to actually, you know, make everything interoperable from the point something's pushed into the screen printer to when it's actually boxed up and becomes a product?
No, I think it's all about collaboration, honestly, because connectivity, when we can create an environment in the manufacturing that actually can become visible to the end customer, where you can actually see an upstream root cause and understand the downstream effect of it and correlate that. I think that's the key thing for success. And also my own experience within the EMS industry is that the more value an EMS provider can provide to their end customers, the more you need to understand your customer's environment. Data is key. And of course, if we can prevent issues and predict errors before they happen, that's a huge benefit. And in line with what Johan mentioned as well, is that when you can have the capability of a push button transfer to basically not just a digital twin, but in essence, a physical twin, where you can have lines connected globally, and you're able to digitally transfer not just the programs, but also the ways of working. That's going to be a game changer.
Yeah, that's a really big deal, isn't it? And I think people have suddenly realized how hard it is to move product from one place to another, and they're going to continue to see that. And there are issues of capacity and all kinds of other things, but actually the fundamentals are part of that challenge. And some companies have set themselves up to be able to do that by having identical equipment sets, but a lot of other companies have got legacy equipment that's come from acquisitions, and the way they built their business hasn't allowed them to have an identical equipment set everywhere. So that digital twin or that digital thread becomes increasingly important. What I want to explore a little bit is the interaction and the collaboration between man and machine, or operator and machine, because I think that's an absolutely fundamental part to what we need in terms of flexibility. What's your view on that?
I think it's the human machine partnership that's what it's all about. We need to create manufacturing flows and methodologies that caters for the fact that we can onboard designs that maybe it's not 100% adapted to it, because as I mentioned, the books that we wrote they're getting old now, they're still valid. So when you can create a design that is actually adopted to automation, that's the perfect solution, and which is not the case in 95% of the cases. So you need to have the mix of a capability to manufacture parts where you can actually very quickly switch in a human that does the actual assembly and switch it out, and then add a robot solution. And one of our solutions, the MCell, one of the MCell solutions, we actually selected the ABB UMI, which is currently the best, for our perspective, the best and most accurate solution on the market, and has the best performance, and not limited to that specific robot or per se, but that has the capability to work side by side with humans. Of course, you need to make sure that you program it correctly, you do your risk analysis, of course, but the methodology of deploying it becomes key, because if we can simplify the programming in the deployment of that and reach what we call the zero-touch programming, where you basically program the entire cell within 100 seconds, you're on the level that the SMT process has been for the last at least 10 years. So and if you don't have to train your robots or the technicians that program the robot that much, then it becomes quite simple to deploy, and then you can augment human capabilities.
Yeah, and I think that word is really important, augmentation. And when we look at the augmented operator, that becomes a really, really powerful thing. And it's picking that process and making sure that the appropriate processes are done by the humans, and the appropriate processes are done by automation. So that planning becomes becomes a really essential part about within that. You talked a little bit about the MCell. Tell me a bit about the approach of MCell, because I think it's quite unique, quite a unique approach to automation on the shop floor.
Thank you, Phil. No, so MCell, when we started developing MCell some 3 years ago, the first thing that we did was consider everything without a robot. So we did the methodology development to try to make, the aim is to make a changeover in less than 100 seconds. So the entire cell should be able to switch between products within 100 seconds, not the SMED approach, a single minute exchange of die, but 100 seconds. So that's been a target. And at the same time, create a cell and a solution that from day one create full traceability. Every movement that is done within the cell should be tracked and traced. And with the purpose of actually creating a cell that has the feature of the capability of understanding its surroundings. So it has to be a floating approach. We can't have, from my perspective, over the years of working with different EMSs, acquiring a lot of equipment, I'm not in favor of those hard automation solutions. I'm not in favor of those very complex automation projects. I want it to be super simple. I want to be able to basically 3D print my fixtures anywhere in the world. I would like to have a standard set of those cells standing at the manufacturer's locations, and then just be able to transfer not just the program, but also the files for the fixtures, the instructions how to operate it, and operator instructions as well as videos. So for us, the MCell solution is, we have now launched the THD solution, the odd form assembly MCell. There's more solutions coming as well using the same concept. So the whole purpose of that is be able to meet the vision of a factory manager coming to work in the morning, having 10 operators and 55 robots standing there, and then being able to super flexible deploy them at different locations based on the current need of what is to be produced today. So shortening the lead time is the key thing.
Yeah, and shortening that changeover time. And we talked a lot about the SMT line and how automated that is, and the takt time of the SMT line, and the changeover time of the SMT line is going to dictate what is a successful implementation. You need to be able to move at the pace of the SMT line, and that's the way we design all our lean cells or whatever else we design within the business. And you need to be able to change over at the same rate that changes over. When you talk about them as digital building blocks, what do you actually mean by that? How does that deliver a kind of a measurable, tangible solution?
So adding capabilities is for us extremely software defined. So we are continuously adding new features and functions to these auto sequencer of the robot. In this case, we have capabilities to update the machine learning part of the robot, as well as our factory intelligence system membrane. But so we have the capability to actually add new features and functions and allow the MCell to learn. Not only that, but also we have added the capability to learn in real time. So understanding the performance of a certain wave solder pallet, or the performance of a certain board, and then basically be able to feed the MCell directly from CAD information. So, and in order for us to try to eliminate as much of the deployment time as possible, and allow the user themselves to design their own feeders, to do their own programs. And I understand, I know, been responsible for a lot of prototyping. If you're going to do 10 prototypes a day, you can't wait 6 months or 3 months to get a new feeder. Yeah. You have to be able to go to your tool shop and get it machined out, and then just run it. You can download it to a 3D printer, print it out, and run it. So time to market is the key thing. So, and that also for, I don't know if you agree to that, Johan, but I think you do, that time to market is key for any EMS, and time to value. Yeah.
Johan, I'll let you come in here.
I agree completely. It's the basic to use a contract manufacturer to be able to get the highest speed in introduction, most competence, proper MPI processes, and ensure that we can get it out faster in that way by using resources that has experience from other areas. So it's one of the fundamentals.
Yeah, absolutely. I wanted to kind of move into a bit more of a debate mode here with you now, because I've got some questions that come very much from what we've discussed. And one of the things that you mentioned, Johan, was this idea of connecting product design. Is there a role for design for automation? Is that something that product designers are aware of, or are they just designing in, it's like Mattias mentioned additive manufacturing as well, and one of the challenges I constantly see in that industry is people don't know how to design with that toolkit. Is automation one of those tools that people need to be trained to product design with?
Yes, I believe so. If you look at the difference between high volume companies and low volume companies, is that the low volume companies have taken out automation in the beginning. We look in terms of maybe smart screwdrivers, but that is for a low volume company or a high mix company a major investment, because it's a significant amount of programming. If we're looking at high volume manufacturers, there is no choice, but there you build the cells so that you can have very inflexible automation, and that is a change that needs to be done. And yes, more automation being considered already in the product design phase, but also when we are considering the process design, when we are setting it up for the production, instead of or in combination with doing the lean work, we need to look at automation, and look at automation from the perspective of lean, not overproducing just because we have a possibility of doing it in a very efficient way.
Yeah. So it's selecting again, isn't it? And when you think of that design process, Mattias, how do you, as someone that is building and designing automation, how do you inform kind of the community that how do you influence the design process? I guess that's where I'm going.
The best component is the components has not been designed in. So that's part of the design for excellence approach that has to be there, is that understanding what components to put in there, what risks they bring, how to control them, how to make sure that they perform well, not just within manufacturing, but also in the field. That information, today we have the capability to use data for that, to understand how is a certain family of resistors performing, for instance, or a certain shape or component type is performing in the field. Those type of information, and at the same time, the brand sensitivity that we have among our customers, no one can afford to have a callback. No one can afford to have a bad performing product. And at the end of the day, 95% of the cost is done at the design stage.
Yeah.
So I think it's super important. It has gained a lot of traction over the last 20 years, of course,
Yeah.
but we are better in designing and modularizing the design. So I think experienced people within design knows better on how to design for manufacturing, but we have design for automatic assembly, which has been around for many, many years, but now it becomes even more important.
Yeah, absolutely. Johan, do you see that happening in the kind of DFM parameters that you build? Does that consider automation now?
Not to the extent that I would like to see it. Collaborative robotics, for example, is an obscurity that is being deployed for some purposes when someone has a huge interest in it. We see it more in transportation with automated guided vehicles, but the technology has been on the market for such a long time, and it's first now that we are being deploying it. When we're looking at the collaborative assembly, it's not designed into the process. We're looking at the challenges we have, and we try to solve some problems that we have when we are bringing it in. It's not part of the DFMs, as far as I'm concerned.
Yeah, and that's interesting. And I think it's very different in the world of, for example, the automotive sector, where everything that they're designing for the last 20 years has been designed to have partial robotic build. So I think there's differences there. What I mentioned earlier on, Mattias, is this idea that the current situation is accelerating digital transformation. Has that been a reality for you? And in the last 3 months, have you seen an increased appetite, an increased desire to look at, maybe stuff is coming back to a particular European location and they want to figure out how they can do it more economically? Are you seeing more inbound?
Definitely. The interests, the timing for us has been really good as well. I'm happy to say that. We see an enormous uptake on interest. We have a lot of new projects rolling out, and I think the situation now with the COVID has actually actualized the need to get full transparency on the supply chains, understanding where things are manufactured, at the same time being able, now we have the challenge, or this, I would say this is the production paradox, where we're looking into having a resilience of parts, and we need to have an overstock because we're afraid of COVID will lock down the supply chain. At the same time, you don't buy milk for 9 months ahead. You need to have the right parts in stock.
Yeah.
So looking through that, and one of the solutions for that is the digital approach, where we can actually create visibility in the supply chain, know where things are, where they're coming from and where they're supposed to be used. And so I believe that the COVID has been a tremendous eye-opener. And if I'm allowed to use another company name, but I think the manufacturing is striving for the Amazon experience, where we can actually produce on demand at point of use. And we did a project with Nokia some 2 years ago. One of the visions that we had when we started with the robotic solutions was to be able to put a factory in a box. Yeah. So eventually we did that with Nokia 2018, which drew enormous attention, and it was super positive, which is a concept, but the purpose of it is actually to exactly what is happening right now, to be able to produce at point of use.
Yeah. So, yeah. And it's a very Swedish approach, if I may say, a factory in a box. I imagine some stuff, arriving flat pack and being assembled when it gets there. And actually that's a bit of a, there's a deployment challenge related to that as well at the moment. One of the questions that we've been asked from the audience is do you need to implement a digital twin for digital transformation, or is that part of the process? How do you see that relationship between the digital twin and the big picture of moving to smart factory? Johan, perhaps you can take that one first.
I would like to leave that for Mattias to start with.
Yeah.
Okay.
I could go at great length at being extremely boring on this subject, So get a little bit focused, Mattias.
Yeah, sure.
Okay.
So to answer your question, Phil, yes, I do believe that throughout the process, the digital twin is as a part of not just knowing the performance of the product or the components or the bill of material or the AVL or the supply chain, but also the process performance. And in order for adding the capability to understand the performance of each machine and robot and process step, it's like you need to actually understand the different parameters. And so that is a part of the journey, not just to have a digital twin, but actually being able to transfer it to a physical twin. So
yeah, okay. Johan, you want to add anything there without being boring?
Yes, I will try to do so. I've worked in an environment where a standardization on machines and configurations has been driven all the way out. There has been no change to the setup for the various machines. Even if we have a separation of 2 meters, if we have 2 different operators, as soon as there is manual intervention, we do have a challenge. Only if we can automate the process completely, we can get the benefit out of the transferability between lines or between sites. And that needs to be done by design. So it's not just to make sure that we have a digital replica, if you call it that. You also need to make sure that all the interactions, all the controls, all the validation is completely identical. There are some companies that has developed tools for supporting those processes, and that is becoming better. And here, the increased use of artificial intelligence is going to be extremely important.
Yeah, and you know the AI thing I think is really interesting. Mattias, I know you use that in some of your products. Do you see the availability and accessibility of AI and machine learning as a game changer?
Yes, full stop. And I think looking into supervised learning, basically, that's where the area we're in. And the reason for that is that within manufacturing, applying unsupervised learning, of course, there is a lot of potential for it, but the time set for the data is not there. You can't have 3 years of data because the product doesn't live for 3 years. So you need to have a short-term data, and it is a game changer because it's a matter of providing the tools to take better decisions. At the end of the day, humans will always be part of the decision, but we need to provide better information so the decisions can be better informed.
Yeah.
And to certainly
automated. Yeah, and made using intelligence. I want to switch gear a little bit because I want to explore the kind of process of actually validating and getting automation in. And to do that, there has to be value achieved, and that whole ROI calculation is a key part of your digital building block model. Mattias, how do you help people within those EMS companies justify the specific investment they're making, and how does that digital building block work in terms of the fiscal side of things, the ROI calculation?
So basically, if you take the MCell THT, what we're starting doing there is that, okay, first thing first is that you have to look upon the design. Is this actually possible to assemble using automation? Of course it is. It's just a matter of how much money you want to spend on it. So the key thing is to get the good mix of course, you need to create value. Of course, otherwise you wouldn't do it. You need to have a short ROI. And then one of the things that we've been working on since day one as well is to adapt everything towards a basic rental model, which allows the customer to have a much lower investment. And of course, over time, then they can use their equipment differently as well. So for us, we bring we do CapEx models, we do rental models, and the key thing is that the customer can choose, and they have the upside to actually be able to redeploy the solutions to other applications, which I believe we have a benefit of offering the customers. That helps the ROI definitely. And
yeah.
the performance of the cells has been really good so far. There's been a long journey developing it for sure. And now it's up and running really good. So.
Yeah, and that return on investment is relatively short. Johan, when you look at that from the point of view of being inside a contract manufacturer as a GM or as an operations manager, you've got to justify that expense regardless of whether it's rental or you know, an outright purchase. What does that process look like, and how do you kind of do that value engineering process to make sure what you're getting does have the right ROI?
For answering the question, I would like to add one aspect into the ROI calculation. The ROI calculations that we are doing today are erroneous. It does not take in the additional cost of managing the labor. I've been operating in Asia with huge amounts of operator turnover, and the result has been very improper processes for managing the labor. And now with the work of the EICC and so on, the cost of labor is increasing as a result, which they should. In addition to that, the pandemic will change the game completely. Most of the costs that we're facing, we are taking on a totally different account. And as a result, we don't see the alternative cost of maintaining a manual process. In terms of doing the ROI and what we are actually taking in, there is an enormous resistance towards data acquisition properly, building systems that communicate with each other and linking it to the automation that is required out in the production. We have a tendency of buying the lowest cost equipment that does not include all the bells and whistles. And the bells and whistles might be what actually makes sense. I've too often seen robotics that doesn't have a feedback loop with a optical system of checking the outcome of the robotic soldering, for example. And I think that we will need to approach the ROI calculations from the complete cost, more holistic cost of what it costs to the factory not having the automated solutions.
Yeah.
That's my take on the question.
Yeah, and it's actually a really complex calculation, like you say. You know, just taking labor rates and saying X number of hours have been saved is a very simplistic approach. But as you say, there's labor loading, there's all kinds of other different issues that come into that. There's the space occupied, there's energy, there's training time, there's so many complex dynamics when you look at the whole calculation. When you then take that to the leaders of these large EMS companies, or manufacturing companies generally, do you think there's the appetite, the commitment, the buy-in at C-level for this digital transformation? And maybe there's more of that now, so it's an opportune moment, but that's contrasted with a bit of an investment fear at the same time.
Yeah, if I may answer to that, I would say that the digital awareness among the C-level of manufacturing companies and product owners is increasing rapidly, and also now due to COVID. So I think we are breaking old habits and bringing automation and digital solutions, and the uptake now will be way much faster than we've seen before. And at the end of the day is that as a manufacturer, the whole purpose is to protect the customer brand, being the manufacturer, being the product owner. And when we can apply digital tools to that, to not just to do predictive maintenance, but also predictive analytics on performance on the products, and of course create data models that are simple to adopt and simple to deploy, that is will be a additional creator of value for a manufacturing company.
Yeah, and actually I had a comment from someone in the audience there agreeing with Johan that it's that it's how do we get that total cost of ownership, that total cost of return on investment, and that's you know, that's really complex in terms of understanding what the return on invested capital is. Johan, when you take these models that you've created to the people holding the purse strings at these large EMS companies, is there a willingness? Are they meeting it with, yes, we're looking for solutions, or hey, you want to spend money? Are you sure? Kind of approach. What's the response like, and has that changed?
Yes, it has changed. If we go back 10 years, maybe 15 years, it was fairly easy to for a high volume product, get the fair amount of investments in a automation cell. Today, I would say that the C-level is seeking automation as solution and seeking projects to deploy resources for. However, in some respects, it's a big projects that are attractive and get traction. At the same time, we have a number of small issues that needs to be fixed as well. That comes back to the industrial engineering. We need to have designed the process. We need to have the present automation equipped fully so that we can limit the manual intervention with them and have validated process rather than going back in and verifying them. And I think that is an area where some of the connections are not being made. I think that if I proposed to someone that I wanted to buy 10 big robotic stations for a production, the ROI calculation would legitimize it. If I then haven't done the homework for a SMT line, ensuring that I have the highest flexibility of it, it would not be a concern.
Yeah, no, it's fascinating, isn't it? And it's really figuring out where those sweet spots are. And one of the things I feel with Smart Factory and with Industry 4.0 is, in many ways, it's often a little bit overwhelming in terms of the number of things that can be done, and it's, you know, it's selecting those what we refer to as digital building blocks that are manageable and tangible for people to actually do. We've only got a couple of minutes, and I want to take a quick couple of questions from the audience again. One question is about the feeding of items into the robotic stations. What are your recommendations there in terms of, you know, how do you get stuff off the SMT line and to the next point? Is that fairly operator dependent?
No, yeah, we're trying to use gravity feeding as much as possible. There are some really brilliant solutions on the market. I can do some commercial for ASICube, for instance. Brilliant equipment. But for us, it's a matter of trying to make cheap, simple working feeders. The customers are able to actually machine them themselves as well. So there are more things coming up from us as well that we're going to be showcasing now during the summer and fall.
Okay.
So that is, it's simplicity is what is.
Yeah. I think that's really important. And Johan, perhaps you can answer this one. When you look at automation in your business, how do you look at the maintenance situation, the predictive maintenance? We can't do predictive maintenance on our operators because we don't know when they're going to get sick, but hopefully we can do that on our robotics. We don't just wait for them to break down. Is predictive maintenance one of the factors that you look at when you're selecting an automation solution?
I don't think it is in most EMSs, but if you look at most process industries, it's an established science. The methods are there, the software is there, and they just need to be deployed on the stations. If we're looking at, for example, an SMT line, yes, there you have the predictive maintenance and preventive maintenance, in most cases, developed to an art. We need to take it into all automations that we have in the plant and approach it in the same way. So maintenance will become more important, and it's going to be a more central function than it has been in the past.
Yeah, and I think, you know, that's part of having that digital thread and the digital twin. You should be able to see that stuff ahead of time, and that's really important. Speaking of being ahead of time, we are pretty much up to the hour. I don't want to take any more time of the numerous people that have joined us from all over the world. So thank you very much to them for taking part. But most importantly, Mattias and Johan, thank you very much for a really, really fascinating conversation and a really interesting presentation. Thank you so much for your time.
Thank you, Phil.
Thank you.
Okay, well, thank you very much, everybody. Keep an eye out for the next webinar that we've got scheduled. We'll be following this up with a link to the recorded version and access to the material that's been discussed here today. And if you've got any further questions, then you'll be able to, following that, get in touch with the two speakers we've had here. In the meantime, thank you so much for your time. Stay safe and look forward to talking to you again soon. Thank you so much.